What's up, YouTube? It's Chillin' Manillas, day 41 on the road to code, 100 days of code challenge. So yesterday we talked about the big O notation and how it plays a role in the algorithms, which wasn't really explained in Free Code Camp. What big O was, that's kind of more computer science, math, which I did look into computer science a little bit, just briefly. Just did a crash course series on YouTube that I found. It actually went in depth. It did mention Big O, but not. It was actually a lot of information that just didn't absorb all of it, basically. But yeah, we're going to more here. This is a blog that I found about Big O notations in JavaScript. 4-minute read. So we're just going to read through it. What is Big O notation? That is a very common job interview question for developers. In short, it is the mathematical expression of how long an algorithm takes to run depending on how long is the input, usually talking about the worst case scenario. In practice, we use Big O notation to classify algorithms by how they respond to changes in input sizes. So algorithms with the same growth rate are represented with Big O notation. The letter O is used because the rate of growth of a function is also called order of the function. What is important? Why is it important to know this? Knowing Big O helps and facilitates developers being aware of the efficiency of an algorithm so they can create applications with good performance. It is usually acceptable that your first version of an algorithm is not the most efficient solution, but the fastest to code, assuming it will be replaced for a more efficient one in future versions. This is a very common practice in agile development, especially in test-driven development. And I did read a book about agile, the agile methodology as well, really good, before I even know how to code. So it's kind of funny. Sometimes we want to focus on using less memory instead of, or in addition to, using less time, iterations, and usually there's a trade-off between saving time and saving space. You can also see this kind of balance between saving read time and saving disk space, or when compromising rational, normalized, or non-relational, denormalized databases. Now let's explore the common types of Big O notations. We will be using JavaScript, ECMA 6 as a reference language, but the same principles apply to any other. Alright, constant time algorithm is O1, which means order 1. In this order, regardless of the complexity, number of items, the time iterations is constant. You'll see this on algorithms that return an element in an already known position of an array, regardless kind or length. And I just show examples here, which I can't show you guys. Next one, linear time algorithm. This one is O parentheses n, and that stands for order n, and it's a capital N. In this order, the worst case iterations grow on par with the number of items. In other words, the n elements, we will require n iterations. And to show examples, again, I can't show it. Oh. And now the next one is a quadratic time algorithm. It's O n squared, which stands for order n squared. For this kind of order, the worst case iterations is the square of the number of inputs. The time grows exponentially related to the number of inputs. Then more examples here. Logarithmic time algorithm. O parentheses log n, order log n is what it stands for. These are the holy grail of search sort algorithms. They are usually the most efficient approach when dealing with large collections. Instead of looking through the components one by one, they split the data into chunks and discard a large amount on every iteration, usually to half or log base 2. Assuming we are using a log base 2, we could ideally find a specific element in the collection of 1 million elements using less than 20 iterations. If we scale the size of the collection to 1 billion, we would require only less than 30 iterations, which is, well, I want to say in this other article that I read that like a billion elements, it would only take a few seconds. I think 30 seconds is what it was. But continuing on, with the big data being more common every day, it's easy to see the advantage of this kind of algorithms, since the larger the collection, the more relative efficiency they can provide. And again, that's tying back to data structures. The most popular of this algorithm is the quick sort algorithm, which can be used to find specific element or sort a list very efficiently. Another example of this order is the merge sort algorithm. We will explore these algorithms on future articles. Okay, well that's pretty much it. This is the conclusion here, and that's how we covered the most common types of algorithms. I invite you to read more. Okay, so yeah, that is it in this short article. I actually read some other articles before this one, which I haven't read. This one just happened to be the shortest one to read on video, so. But yeah, I've read like 3 other articles on Big O as well. But I did also do some more free CodeCamp courses, which is Object. It's I don't even know what it's called. Let me look right into it. But I did do like half of that, which is, I want to say, just trying to get the right name for you guys. It's not even that important, but already waiting. Alright, object-oriented programming, there we go. Yeah, so like halfway done through that. Also just going back and doing flashcards, trying to just memorize the syntaxes of stuff that I didn't get right in the classes. Definitely piling up a big stack of flashcards. But yeah, that's just repetition as well. But that is pretty much today's update. Hope you guys have a good day. As always, like, comment, subscribe. Check out the blog at trillamanila.com and Twitter at trillamanila as well. Peace out.